In this video, I'm going to go over problems 3 and 4 from the 1.0B homework in Math 141. So this first one here, 1 minus 2 divided by x plus 1 equals 2x over quantity x plus 1. So this is a rational equation where we have denominators. We can't cross multiply because we have this 1 over here as well to consider. So what we want to do is clear the denominator. We can do this because it's an equation. We can use this technique for equations and for complex rationals or fractions within fractions. We cannot use this technique when we just have an expression. We would just have to get common denominators and perform the addition or subtraction involved. You could go that traditional route with this one too, but it's nice and clean to just clear those denominators out. So the process would be, just look at your denominators and get a common denominator. So a lot of times just multiplying them together if they're all different, but this one I have the same thing. So I want the lowest common denominator. So x plus 1 will work because if I multiply every term on both sides, so really what I'm doing is multiplying the entire equation by x plus 1, and when I do that, then the denominators will clear out because it'll become 1 over 1. So let's take a look at how that works. I'm going to, so in essence, what I'm doing is multiplying this entire equation by x plus 1, in parentheses if you want to put those in, and then distributing. So what it will look like in the next line, and you wouldn't necessarily need to write this all out, you can kind of squeeze it in on your worksheet if you want, but I would have x plus 1, and if you want to put it over 1, that's a good idea, times 1. So I'm hitting that first term, and then if you want to put that over 1, sometimes that makes it look nicer, and then subtract. Don't forget to bring down your subtract, or you could make it be, add the negative if you like that. And then I have 2 times x plus 1 over the denominator x plus 1, and then equals the 2x times x plus 1 that I'm distributing here over this denominator x plus 1. So you can see how now I have the x plus 1 over x plus 1 would reduce out. So a lot of times I don't write out all those steps, and you don't need to either, but just to show you how it works and how it looks and what I'm doing. If you haven't used this technique in the past, I want to make sure you get the concept of it. So then from there, I would want to just go ahead and multiply out. So I have x plus 1. Then I have minus 2. Just remember this went to 1, so I'm done there, equals 2x. And then I go ahead and solve. Just remove the parentheses on this. We don't need them there. So there's no negative in front or anything, no coefficient. So I just go ahead and simplify this. Now it's just like a linear equation. So I would have x plus 1 minus 2 would give me an x minus 1 equals 2x. And then I would subtract the x from both sides. And again, I'm writing out some extra things that you wouldn't necessarily need to do. And then I have negative 1 equals x. Okay, so the thing with this, you just switch it around, x equals negative 1. Does that work for this equation? So you might have gotten this one wrong because you just left it as x equals negative 1. But if we test that, test the answer in our original problem, look here, we have an issue because negative 1 is going to make our denominator go to 0. So you could have set your domain ahead of time. Domain is all real numbers such that x is not equal to negative 1, because that will be when it goes to 0. And we'll review domain and range in section 1.1 and 1.2, I believe. So if that's something that you're not familiar with or just haven't had in a while, I do go over that. So so this one, what happens is I would have the -1 plus 1 would equal 0, and then it would make it undefined. So this is extraneous. That's what we call that. So therefore, there is no solution, or you could say, you know, it's the null set, which kind of looks like that. So up to you. These 3 dots mean therefore, a shortcut for that. All right, so that's it for number 3. I'm going to go right into number 4. Okay, so for number 4, this is called a literal equation. And we need to solve for h in terms of all the other variables. So what I like to use first is the clearing of the denominator, or you could think of it as cross multiplying, but I'm going to multiply both sides by e. And when I do that, these will reduce. And in this next step, though, I get e times e would be e squared. D plus h equals h. So that's where I'm at right now. Again, you might be able to combine, like, you know, do stuff in a quicker way, but I just want to make sure I show it all out. And then I'm going to distribute. So then I would have e squared d plus e squared h equals h. Okay, so we're clearing, and then we're distributing. The next step is now to collect, just to make it be, you know, something quick to say. But what I'm doing is getting the h's to one side, and I'm just going to get them to the right hand side. So I'm going to write it as e squared d, and I'm going to subtract the e squared h from both sides. So I end up with h minus e squared h. They're not like terms because of that e squared. We don't have exactly the same variable parts, so we can't combine them. So now I have my h to one side, and then I need to factor again. So I need to now pull that h out and separate it out. It was trapped up in here to begin with. Anytime it's trapped up, you got to release it by distributing. Then you got to collect it to one side, and then you got to, you know, kind of refactor, but you're factoring out an h this time instead of the e that was originally pulled out there. So now we go back to our e squared d equals h, and then this is where I think people get a little tangled, is you have to put that 1 there. So when you pull out the h, you're left with a 1 minus e squared. Okay, so that'll I've noticed just on some of the work I've looked at that 1 gets kind of lost in there. Now to get h by itself, I can divide both sides by 1 minus e squared, 1 minus e squared over here. And then my final answer is h equals this part here, e squared d over 1 minus e squared. Now you might have gotten a little bit different version of that with some negatives and such, but if you just factor out the negative and rearrange things, it really is equivalent to the same answer. And then you would just leave your answer like that. There's no test to do for to see if we have an undefined situation or anything. It's just a literal equation. right, so I hope that helps. I'm going to do another video for the next couple of problems that people have requested. Have a great day.